Hi there. In this video, I will tell you how to install MicroPython on a Raspberry Pi Pico using Linux. So I have a Raspberry Pi Pico board right here, which is a Raspberry Pi Pico W, by the way. You can identify that by this chip that you find in here. This is the WLAN chip, which is found on all the Raspberry Pi Pico W boards. This board came without a header. I had soldered the header already on my own. And yeah, the soldering is not the best. It's hand soldered, so it's not as good as a machine soldering, but it gets the job done. When you have this board, and by the way, this board already has a firmware installed earlier. Many times when you have a board installed with an existing firmware, you want to reflash it. You want to add, you want to update maybe MicroPython, the newer version of MicroPython on this board, or maybe the firmware is not working and you want to just reflash it. You might want to hold this button that you see here. There's a boot cell button that you see here. You need to hold this button when you connect this board onto your computer through USB. Of course, you have a micro USB port in here, and I have a micro USB cable with me, which I can connect onto this board. And then I can also connect the USB side onto the free USB port on my computer. So you can do the same, right? So I'm just going to connect this on to my computer, the free USB port. And now before I connect the micro USB onto this board, because there is an existing firmware, you might want to hold the boot cell key and then plug this in. You need to hold it on for like 2 seconds. You will normally hear some kind of a beep sound if you have a desktop with, notification for external devices being connected. You will hear that sound. That's the same case like on Windows and Mac OS. You'll find the same on Linux too, with modern desktops. So once this board is connected, now you are ready to access it using a file manager. By the way, I also should remind you that if you're using a cable to connect the Raspberry Pi Pico, make sure you get a USB data cable. There are a couple of micro USB cables which will not work with, will not source data because they may not have the data pins in them. They're mostly meant for powering devices. So if you simply have a power cable, this may not work. You may need a proper USB data cable to connect it. So if you don't see the drive coming up on your file manager in any platform, be it Windows, Mac OS, or Linux, though you think that the board is working and everything is in order, it's very likely that your cable might be faulty. Just try changing the cable. And yes, as I mentioned, if you don't hold the boot cell key and if you connect this device, you might not see a drive if there's already an existing firmware. This already has an existing firmware and this will not show up if I don't hold the boot cell key. I had to hold it to make sure that the board switches to reset mode where I can flash a new firmware, right? I did that just now. So let me just head on to the file manager and show you. All right. So when you open up your file manager, I'm using GNOME desktop. You might be using different kinds of Linux distributions. You might be using Debian, or you might be using Fedora or SUSE Linux or Arch Linux. It may vary. There are several thousand distributions of your choice, so you can use any one of them. But no matter what distribution you use, if you're using a graphical user interface, they will generally have some kind of a file manager for you to work on. You can use that. I'm using GNOME desktop on Ubuntu, so you get the GNOME file manager in here. You might also be using KDE Plasma. In such case, you might have the file manager available in Plasma, which might also show up the drive listings in here. So you should be able to locate a drive with the name rpi-rp2. This particular drive is automatically mounted, so you can check the mount point, which is listed in the tooltip right here. You can click on this to open it. You'll normally see two files in it. You'll find a file called index.htm and info.uf2.txt. You can read them at your leisure. They will just give you instructions to flash the firmware. Basically what I'm telling you right now is covered in this document. So you can, I will just leave it at that, and I'm just going to open up the web browser and head on to the website, which is micropython.org. When you're on micropython.org website, you can select the download link here. And Within downloads, you have a lot of listing. It's easy to just select the vendor list that you see here. You can choose the vendor for this board. Apparently, because you're using a Raspberry Pi Pico or Pico W, this would be Raspberry Pi, of course. I'm just going to select that. You can also scroll down these images and look up for Raspberry Pi in here or whichever board that you're using. If you want to put MicroPython on different other boards, right? You can select the firmware accordingly. But then I find it easy to just go to Raspberry Pi here, and this opens up a new page which shows all the board listings for Raspberry Pi Pico alone. And there are two models being listed here. One of them is for Raspberry Pi Pico, another one is for Pico W. Because I'm using a Raspberry Pi Pico W, I will be flashing it on that device. As you can see here, I'm using a Raspberry Pi Pico W. I'm going to flash it on that. If you do flash Raspberry Pi Pico image on a Raspberry Pi Pico W, I tested it once and it worked. I'm able to get through the MicroPython, but you'll not be able to use the WLAN controller. There'll be no libraries for Wi-Fi connectivity. That is a limitation. So if you're using a Pico W, select this. If you're not using a Pico W, select the first one. So I'm going to select Pico W here, and the board is listed just for confirmation how my board looks like. And I'm going to select the latest firmware that's available. It's 1.21.0. This is the latest release as of 2023. I'm recording this on October 23rd, 2023, and looks like just in the beginning of this month, on October 5th, this new release just happened. So I'm just going to download this release. When I download this, you can either put it on your download folder and copy it, but it's very convenient if you're using a graphical user interface to just select the drive, which is already being mounted, the RPi RP2, select this link, right? Select this drive, and then copy the file right there. The file is copied. You can see that this drive would vanish. It'll take a few more seconds. Yeah. You can now see that the drive just vanished. You can see that it's no longer listing the RPi RP2. It went to my home directory now. So this shows that the firmware is written on to the Raspberry Pi Pico board right now. So at the moment, you can now test it by opening up your IDE. I'm using Thonny. So Thonny is most popular for writing code in MicroPython. Looks like my Thonny is pre-configured to connect to Raspberry Pi Pico, so it open up the MicroPython prompt. But if it's not, you might see a standard Python prompt. If you don't see a MicroPython banner, this is what you might need to do. You might head on to Tools, select Options. Under Options, you can select Interpreter. And here below, make sure you have chosen MicroPython for Raspberry Pi Pico. So once you selected this, in port, you might want to select the port. You might get a lot of post listing based on what all devices you connected via TTY USB series. But you will see mostly Raspberry Pi boards will show up as board in FS mode, board CDC, /devs as TTY, ACM0 or ACM1 or ACM2, any of these device names. So you can just find that, select it, and click on OK. And now you added the MicroPython prompt. You can test it by just doing a couple of things. For example, you could try from machine import frequency, and you can just type frequency here. It shows the clock frequency of the CPU inside the Raspberry Pi Pico. It looks like it's 125 megahertz at this moment. You could also use import OS and os.uname to verify that it's really running on the Raspberry Pi Pico. It shows system name is RP2, node name is RP2, version, and you can also see the machine being listed as Raspberry Pi Pico W with RP2040. This shows that MicroPython is successfully installed on this board. Now, in case you want to, let's say, try out some very basic examples in here, you can also do this. You can actually do a from machine import pin, and if it's p is equal to pin of LED, and then pin.out, and Here's an interesting one. A lot of tutorials on the internet, a lot of other materials might show you pin of 25. They'll give you a number, pin of 25, pin dot out. That would work if you're using a normal Raspberry Pi Pico, like this one. This board would support that. This is not a one with Wi-Fi. But if you got one with the Wi-Fi chip, like I have connected in here, like here, this got a Wi-Fi chip. This will not work when you use pin of 25. There's a small difference because the GP pin 25 on the Raspberry Pi Pico boards are connected to the onboard LED, but however on a Pico W, the LED, the onboard LED is connected to another chip, right? Not directly to GP25. In order to access that other chip, the hack or the solution as per the data sheets provided is to actually use the string called pin of LED. So you say pin of LED as a string and say pin dot out. Once you have selected this pin, if it doesn't throw any error, it works. You can now try pin dot on. You turn on the LED. I'm going to focus this on the camera so you can see it closer and press enter. You can see the LED is turned on. The onboard LED is turned on here. You can turn it off by using P dot. Right? This shows that the board works. This is like the hello world for testing this board, right? So far, I showed you how to do it with the graphical user interface, which is pretty straightforward. It's no different than how you do it on Windows or macOS. But if you're a Linux user, it's also possible that you might be using a bare-bone Linux distribution, which or a bare-bone Linux environment or setup, which does not have a graphical user interface. In such cases, if at all you want to connect to the Raspberry Pi Pico, you might want to do it purely from the command line. I'm going to show you how to do it on the command line now. It's pretty straightforward if you know basic command line tools on Linux. So I'm going to close all these off and open up a terminal instead. Let me just zoom the terminal screen a bit. If you're on terminal and if you want to purely know or purely connect through the terminal and make things work, these are the things that you should know. First of all, you should have downloaded the firmware image. One way to do that is if you know the link to the firmware image, you can use a command line tool to download it. So I will just use a quick hack for that because I don't remember the link. So I'm just going to go to MicroPython one more time. The web browser. You could also use a command line web browser and download it from there. You could use elinks or any command line web browsers if you have installed them. But then I'm just going to use the download link. I'm just going to copy the link. I'm going to right click, copy link address, close the browser, you don't need it. Now for command line downloading, you could use various tools. One of the commonly used tool is wget. You could also use curl, or you could use aria2c if you are comfortable using that. There are various tools available. It's a very small file. You don't have to worry about, you don't have to be very picky about the tools. The file is very small. When you're looking at large file downloads, you worry about which tool will let you download faster and reliably. So I'm just going to use wget at this moment and just paste this link. I'm going to use middle click on my mouse. That's what works on this terminal. So I'm going to paste this link and I'm going to press enter. Looks like the file was already downloaded on my computer, so it did not show any progress bar. But if it was not, you would have seen a progress bar coming up showing you the progress of the file being downloaded. Once this file is downloaded, the file is downloaded under this name that you see here, rpi_pico_w the release. So I'm just going to copy this file onto this board. Now, if you are on the command line, same process. I will use this here because I think I'm sharing the screen. Okay, I will just toggle it temporarily. Yeah, here it is. I'm just going to disconnect it now. And at this moment, same story. I'm just going to use the boot cell, hold the boot cell key and boot cell button here, keep it held, and connect the micro USB port. Keep it held for like 2 seconds and release it. Once done, let me rest this board in here. Hopefully, yeah. So it's aligning things. All right. So once this board is connected, now the next step is from the command line, you can verify what device this board is recognized as. The moment you run sudo dmessage, you can actually see that there are a lot of errors over here. You can ignore that, but you can see that it shows up USB storage, USB mask storage detected, and you can see some attached SCSI generic device, and you can also see the device name here. It's called SDF on my machine. These labels can keep changing. It can keep you can get it as SDB, SDC, SDE. Looks like whenever I connect, disconnect, reconnect a couple of times, the letter gets updated. I've just observed this. I think this is more like the 5th or the 6th connection I'm making right now on this board. So you can actually see there is a device called SDF on my machine, and you can see SDF1 on your machine. Just note down the label for this drive, right? What this device name is known as. And once it is known, once you can find this out, you can also run lsblk, and unfortunately lsblk can be cluttered on a couple of desktops. If you especially have a lot of hard drives, and if you have something like Ubuntu which uses Snap, you see a whole lot of clutter with a lot of loopback devices being mounted. So it might look a little crowded in here, so it might be a little confusing to find out which device is connected. The sure short way to find out is always, as soon as you connect, just run sudo dmessage on the command line and then look up what you see as a last USB mask storage device being attached, and that is a more clear way to find out. And in my case, it's confirmed that it's SDF1. The SDF1 is the actual drive that you need to mount. Most graphical user interface will automatically mount the device, but if you booted Linux on a command line, purely on the command line, the auto mounting might not be there on your setup until you specifically configure it. So if it's not mounted, you can mount it manually by running the command sudo mount /dev/sdf1 in this case, and /mnt. You might change that device name accordingly based on what you see from the dmessage listing. You might see SDB1 or SDC1 or SDD1 or whatever. You can just select that. So in this case, in mine, it is SDF1. A short way to confirm that is when you do a ls/mnt, which is now the new mount point for this device, you should be able to locate the same files, index.htm and info.uf2.txt. You're able to see this file, it's all good. Now you can write the firmware image onto this device. I already showed you how to download the file using wget command a while ago. So now I'm just going to copy that file onto this image just by using the good old cp command. So can you cp rpi underscore, I'm just going to use tab completion. It's more convenient. Use a shell that supports tab completion, so it will auto-complete the file names so you don't have to misspell them, right? So you can see that the file is actually downloaded under the name rpi underscore Pico W hyphen the release number with a .uf2 extension. So just need to copy this file onto the newly mounted location. That's the /mnt folder in my machine. And this will take a few seconds. And once done, you will see that the drive would be automatically unmounted and removed. It's done. So you're back at the shell prompt. Once you're in the shell prompt, I'm just going to run sudo dmessage another time, one more time. You can see a USB disconnect message, and then you can see another USB device being connected. And you can see that USB device showed up with manufacturer MicroPython, board in FS mode, and more important, you will see this device name. This device name could be quite useful to note down, because if you're going to be connecting this device through any special tools, any command line tools, sometimes you might need to specify which device to connect to. This is a device name. I've seen that if you're using other devices, most likely you will see it as TTY USB 0, like I would have told you already when I showed you in the Thonny interface itself, but then it is shown up as TTY ACM 0 for this device. So now once you know this, you can actually access the device by using a command line tool called Rshell. Rshell must need to be installed on your computer, and this requires Python. So if you have Python set up, which is very likely the case in most Linux deployments today, you can just type Python minus version to verify the version of Python you're running on. I'm not using any specialized version of Python like Anaconda Python at this moment. This is a default Python setup on Ubuntu. I'm using that. In fact, when I run which Python, it'll in fact show you that it's coming from the user bin folder. And here's one interesting thing that's happened in the modern distributions, by the way. To install packages in Python, installing in new Python libraries, normally we use pip install and you could run Rshell like this, but this no longer works. If you try running this on your standard Python setups on Linux, you'll get this error. Yeah, you're greeted with a big fat error here. A lot of details. You can read through it. What they are actually telling you is that if you want to install any Python libraries, the suggestion is to use the library maintained by the distribution vendor for better stability of your system. We don't know whether Rshell is provided by Ubuntu. There's one way to check is looking up their repositories. Maybe try a apt install python 3-rshell and see if it works, and that's one option. But then if you're going to be using any distribution for that matter and you don't want to install Rshell system-wide, you want to have it in your own virtualized environment, it's always suggested that you use a separate virtual environment for your projects. And that's a good practice now. So if at all I want to use all my RaspberryPi Pico projects kept in a specific folder and maintain it from there, what I would do is create a virtualized environment for all the Python libraries to be used for RaspberryPi Pico. To do that, you can actually run Python -m venv. I'm going to clear the screen to show you that better. So it's a Python -m venv, and you can just type R. I'm in my home directory. Let me just confirm. Yeah, this is my user's home directory. So this is where I have write permissions. So obviously I want to create it here. You can choose to create anywhere you want where you have write permissions, right? So maybe in some subfolders in your home directory generally. So I'm just going to run this command again. This will take a few seconds to a minute depending on your system settings. And yes, it's got back to the command prompt. Now there should be a folder called rpico created, because that's what I mentioned in here. This will be a new folder with that virtualized environment for running Rshell or any other tools that you want to install to work on the Raspberry Pi Pico, let's say. So I'm just going to go to this folder, Pico. And once you're in this folder, when you run ls, you can see a couple of subfolders in here. One of them is a bin folder, which is of importance. You can run the command called source bin/activate. And for the source built-in to work, obviously you might be needing to use the Upbone compatible shell. Bone shell, bash, ksh, z shell, any of them will do. And yes, some of you might say, can I not use dot? Yeah, you can also use dot space bin/activate. Just that the word dot, the single dot might be missed on the video. I'm just typing the full word here. You can also use dot space bin/activate. But here I'm just going to type source bin/activate. Once done, you should see the prompt change with a prefix like this. It shows up rpico in the parenthesis. In fact, when you run which Python will no longer be sourced from this user bin folder like it was by default. It now comes from this virtualized environment. And yes, when you run pip list here, it doesn't show up any of the system packages installed. It's a completely new sandbox environment for testing. Now here I can do a pip install Rshell. Looks like I had to install Rshell earlier. I guess I did that through Anaconda environment, so it just took the cached version. But in your case, it'll download it. If it's the first time, it'll just download it and install it for you. Shouldn't be a problem. It works on all the modern Python runtimes. So once Rshell is installed, you can run a pip list to see the listing of all the packages installed. You can see that Rshell is installed as a Python package along with its dependencies. Now, in order to get started with Rshell, you can just type Rshell command as is on the command line. If all goes well, as long as your Raspberry Pi Pico board is connected and working, you will see that it detects it automatically, and it also does some checks, and ultimately it reaches on to the Rshell prompt. At the Rshell prompt, which you see here, you can actually type command like help to get help for basic commands that you can do. For example, you could run ls. Ls will list contents in the current directory. Yeah, that's what it does. But then if at all you want to launch a REPL, you can just type REPL. So the moment you type REPL, you can see that it enters REPL, and you can see the MicroPython banner as usual. And now you're greeted with a MicroPython prompt. And here you can try all your Python code using MicroPython features, right? For example, let's try blinking the LED on this board right now. Just turn on the LED, not blink right now. I'll just turn on the LED for testing. I can use from machine, import pin. Like I did in the Thonny editor, I'm just going to type p is equal to pin of LED and pin dot out. And now I can just type p dot on. But I press enter, let me just show you the board in this camera at this moment, right? So you can see that in my camera. You can, when I do a pin dot on, you can see the LED lights up. I can do a pin dot off to turn off the LED. So this works. So now, in case you might wonder, how do you write real programs, store them in .py files, and store them into this Raspberry Pi Pico board purely from command line? The way you do that is first you need to exit the REPL. In order to exit the REPL, you might be tempted to type the Control D. When you type Control D, it just restarts the REPL. You can see that. It just restarts a fresh instance. It just exits and restarts the REPL. It's called soft reboot. But then if at all you want to exit back to the Rshell prompt, you might want to do this. You might want to type Control X. It's listed right here. Right? As soon as you enter REPL, it gives you a banner. It says entering REPL, press use Control X to exit. You can type the same thing. You can type Control X. It exits back to the Rshell prompt here. And now when you're at the Rshell prompt, you can now type edit and any file name, blink.py. Looks like this file was existing earlier, so I'm just going to delete it and recreate it again. Yeah. So now here I can just type from machine import bin. Don't also say from time import sleep, and then I'm going to write it simple. I'm just going to first initialize the pin and say p is equal to pin of LED and pin dot out. And I can use a small while loop, and within this while loop, I'm just going to use p dot toggle this time. The toggle method on the pin object will just toggle from on to off and off to on. If it was off, it turns it on. It's on, it turns it off. So you can just toggle the LED, right, on this case. And I'm going to use a sleep, which I imported from the time module you see on the second line. And I can say sleep of, let's say, 1 second. And this goes on forever. I'm going to save this file. All right, now that the file is edited and stored, you can see that file is stored locally on your computer right here. You can see it's stored in the virtual environment that I created. It's called blink.py here. In order to copy this file onto your Raspberry Pi Pico or any board that you connect and you want to access through RPi, you can actually run ls/pyboard. This shows the contents of my Raspberry Pi Pico board. It's empty. I'm going to copy this file blink.py into this location. So the moment you say cp blink.py /pyboard, this special hack, the /pyboard, right, is a virtual path here. This copies the file onto the Raspberry Pi Pico board now. It's done. Now you can try running this if you want. And in order to run this, so you could actually use the REPL by using the command this way. You could actually type REPL. One moment. Yeah. you can just type REPL, and you can just launch a REPL directly by just typing REPL in here, and you could run a command import blink. The moment I run import blink, I will just bring this closer to my camera. It's more easier. You can see that on my camera, and yeah, when I press enter, you can see the blink working, right? You can see it's blinking. You can type Control C to exit this. It's a quick hack. Well, I would say that Rshell does not have a direct way to run a script as yet. Looks like that feature is lacking. There is another tool called Adafruit AMPy to do that. For now, if at all you want to just upload a file, copy a file, list contents of the Raspberry Pi Pico, for that you can use the Rshell. For basic execution of your programs, you can just trigger a REPL and import that program name. One of the other ways to do that is if you're not in the REPL, but if you're in the Rshell prompt, you could also type REPL, put a tilde here. After tilde, whatever command you type, whatever option you type will be sent as a command inside the REPL. So you can just type REPL space tilde space, and you can type import link as an option. And this also works, as you can see here. And you can use usual type Control C to exit this. And yes, some good practices I would recommend is this. Sometimes, if at all you type Control C when the LED is on, it'll be left on like you see here, right? The LED is left on here. But if you don't want to leave this LED on, you want to reset everything when you're typing Control C, abruptly canceling the program, you might need to slightly improvise your program to handle this exception. You can do that by going and editing this back. Just type edit. This time I'll type /pyboard /link.py. So you can directly open this file from within your Raspberry Pi Pico using your favorite editor. It could be Vim or any other command line editor of your choice. And by the way, when you run edit, it'll use the default editor that you're configured on your machine. In my machine, I've configured Vim. Some of you might see Nano editor coming up if you don't have Vim installed, or if you have your default editor as Nano. I have configured my default editor settings to Vim on my machine. You could get Nano, you could get Emacs, whichever editor you have configured as the default in your editor environment. So by the way, so here, if at all I want to gracefully exit when I type Control C, just make sure you put this main code which is there, this loop especially, which you want to break out of, inside a block, which is the try block. And you can handle the exception by typing except keyboard interrupt. And then here you want to reset the LED, you can just type p.off. Turn off the LED when you exit. You can also print a nice message. It will show up on your REPL, which is shutting down. Just indicate that you're gracefully exiting this program. And now once you've done this changes, you can save this file. And you can see that's being updated. Now if you try running this again by typing REPL tilde import the program, right, which I gave. And remember, when you're importing your program, your file name ends with a .py, but remember the module name is not a file name apparently. Yeah, only the file name component is used. You don't use the extension. You don't say .py. It's not going to work. You have to type import blink as is. So the file name component without the extension is treated as a module name when you treat a program as a module. And also the fact is that the file name must start with an alphabet or underscore. All these Python rules apply. Okay, so now I'm going to run this program one more time while I keep this in front of my camera at this moment. And when I press enter, you can see the LED is blinking. And now if I want to just, let's say, cancel this, when I press Control C, it's now more cleaner. It's shutting it down, basically turning off the LED and then exiting, right? So this is a basic example on how you could write your program, either using Thonny IDE, which is very convenient for people who use graphical user interface. It's pretty straightforward. It's designed to work with MicroPython. by default. But then some of you who want to work purely on the command line and want to do things the hard way, I just showed you how to do it using Rshell. There's also another program called Adafruit's AMPy. I will just cover that in the future video. I hope this video has already become quite lengthy, so I'm going to stop it at this. So I will talk about the other command line tools to work on Raspberry Pi Pico in the future videos. I'll also give you some. I'll also talk about the Raspberry Pi connections itself and connect to various sensors in in the upcoming videos. I will maybe show examples of connecting some basic LED sensors and temperature sensors and so on. But we will also focus on one more very interesting program which I'll be talking about, which is basically working with a 7-segment LED where we write a driver completely from scratch for a very basic 7-segment display like the one that you see here. We're just going to write a program to manually control the 7-segment LED in the future videos. So if you are interested in videos like this, stay tuned for more. So if you have any questions or doubts, feel free to post them in comments. I will answer them when I see them, right? Thank you very much. So hope to meet you in future videos.